Welcome everybody to Phenotype February week 2. And we are off to a wonderful week together. And this week starts today with a few demos. But before we go into the plan for week 2, let's recap what we accomplished on week 1. During week 1, we planned to focus on defining what the study leads need in terms of their phenotypes. And to help them with that, the week 1 was focused on creating clinical descriptions for all of the clinical ideas that the study leads and their teams want to incorporate in their research. And now I will show you a couple of stats and examples from this clinical descriptions. First of all, we're having 14 studies. I want to thank very much the study leads because we had wonderful engagement through the office hours, through the emails, through the channels. And it was wonderful to see how many interest there is both from the study leads and from the community who expressed an interest in participating in the individual studies or helping with individual phenotyping tasks. And for clinical descriptions, out of 14 studies, we had 10 of the studies are done with their clinical descriptions for their phenotypes of interest. And the clinical descriptions really meant to help the study leads clarify what exactly they're looking for. And those clinical descriptions were very useful for the partners and team participants to understand the clinical ideas behind the study. We saw a lot of variation in how people approach descriptions naturally, varying from 2-page documents to 25-page documents, simply alone based on those clinical descriptions. There were at least 3 conversations that I personally participated in that were very useful, stemming just from describing what people wanted to study. And we had a lot of nice conversations on the office hours with quite a nice attendance. And because people approached clinical descriptions differently, depending on what they want to describe and depending on the level of the granularity that they wanted to provide, I wanted to highlight one of the clinical descriptions that I found particularly useful. That clinical description is for Crohn's disease. And the very first thing is that it was a nice, concise description. It was a one-pager, so it was a very convenient thing for me to skim and understand the details about Crohn's disease that I was not necessarily aware of. It provides a very nice overview of what the disease is in the first block and gives some numbers about the incidence of the disease. It also talks about presentation, and you can see that the description is nice and concise, which was, again, very helpful. And the presentation talks about how that condition can present in clinical practice. For example, that patients oftentimes experience diarrhea and abdominal pain. It also mentioned more specific symptoms and presentations, and it was both useful for me to understand the condition, but it also will help me down the line as I will be reviewing the phenotype, because now I know what I'll be looking for. I'll be looking for the abdominal pain, diarrhea, fistulas, and other presentations of Crohn's disease. It also talked about the assessment. In brief terms, it described how Crohn's disease is diagnosed in clinic, which is imaging, biopsies, and it mentioned the differential diagnosis, those conditions that clinicians oftentimes exclude to make the diagnosis of Crohn's disease. And that paragraph helped me to identify the items and points that I want to look and dig into further if I'm not familiar with them. But it also provided a very nice, concise overview of the tests that are used in clinical practice. And yet again, just knowing this will help me a lot in reviewing patients that down the line will be included in my phenotype. The second part focused on treatment. It described different kinds of therapy and drugs that are used for treatment and how this treatment is initiated and what is the maintenance treatment. Again, you can see very concise, but lists out the drug classes, lists out the individual ingredients. So that was very useful for me. And then finally, it was the final sentence and section was prognosis to give a better idea of whether you expect these patients to have a long-term disease or is it something that resolves quickly. So in general, I found this definition to be very useful because it hit all of the points I'm interested in: presentation, assessment, prognosis, and treatment plan, and it was very concise. So I hope that the study leads had the same experience, that clinical descriptions help them to clarify their ideas that they want to study and also help to communicate those clinical ideas to their participants in their teams. Based on the clinical descriptions and based on what the study leads outlined, what we have so far to do is 201 phenotype. And we are switching gears from the clinical descriptions that they built to the phenotypes that we are about to build. So altogether in our tracker, we have 200 phenotypes. What is nice is that 100, almost half of them, are exposures, which tend to be drug cohorts that we expect that we as a big team will get through rather quickly. But we also see a substantial number of outcomes and indications. So this is something we will be working on for the next 3 weeks. What is nice is that there were 63 phenotypes out of those 200 that were available in Phenotype Library or in other sources, Legend Type 2 Diabetes being a good example of the study that we got the phenotypes from. And those 63 phenotypes will be reused either as is or will be modified based on the clinical descriptions and study lead preferences. So at least it gives us the hope that at least a quarter of those phenotypes we already have in the pocket, either ready to go or requiring minor modification. But of course, all of us will be working hard on the rest of them during these 3 weeks, which nicely transitions us into the week 2 and what we will be doing during this week 2. So now I will pass. During week 2, we will be focusing on building concept sets and logic. And today we will have 2 wonderful demos to give you an idea of how we approach building concept sets and creating logic and atlas. And I will pass the screen to Tanya, who will start with the concept sets, and then we will move on to Kevin, who will talk more about the logic creation using existing tools. And Tanya, the floor is yours.
Thank you, Anna. Hello, everyone. So let me share my slides for a bit. So Anna has already talked a bit about how we arrived to where we are now. And I'm just going to reiterate that currently we have clinical descriptions of the phenotypes that we want to build, and using AI logic as well as literature search, we came up with those descriptions, as well as for this example we're going to be talking about today, first episode psychosis, we came up with lists of codes that are commonly used in literature, in this case ICD-10, for the conditions that we want to include or exclude from our phenotype of first episode psychosis. So just in short, we want to include psychotic disorders, schizophrenia spectrum disorders, brief affective episodes with psychotic symptoms, and we want to exclude drug-induced psychosis and organic psychotic conditions. Here is an algorithm that we're going to be replicating, and this could be a good starting point for you if you're creating your concept set from scratch. So basically, the most important point here is that it is an iterative process. So no matter where you start from, you would still need to check the codes, the concepts that are in your concept set, both standard and source, you would need to check the recommended output or Phoebe output and iterate, add any concepts that you wish to add, remove irrelevant concepts, and this way, by iteration, you would arrive at your desired concept set. And now let me switch to Atlas demo, where we're going to be doing our concept set for first episode psychosis. So here we have Atlas, and I'm going to go into the search tab right away. And as I mentioned, we are doing first episode psychosis, and one of the terms frequently found in literature is psychotic disorders. It is a psychotic disorder after all. So let's just type that in here. And I'm going to click on a shopping cart icon so that it would create a concept set for us to start with. And we're going to go to a concept set expression and see that Atlas has already found us a perfect standard concept for what we were searching for. So it is psychotic disorder with descendants. And why did it choose this one actually? It's not only because it is 100% similar semantically, but also because it is the concept with the most frequent descendant record count in Odyssey evidence network. And these counts are now in Atlas demo thanks to Claire Blacketer and her study. So just a shout out once again, this is a wonderful new addition. So we have our first draft of a concept set. Let's look what is actually in there. So we're going to go into the included concepts tab, and we're going to once again filter and sort via DRCs out of evidence network counts, and let's look at what we have. So first, we have codes for psychotic disorder, schizophrenia, schizoaffective disorder, other types of schizophrenia, and so on, exactly what we wanted when we were doing our clinical description and literature search. So we have other types of schizophrenia, and then we come across something that we actually would not want to see. So here we have a concept called psychosis and severe depression concurrent and due to bipolar affective disorder. So for the purpose of this study, we decided we do not want to have psychosis that are clearly attributable to other chronic conditions such as bipolar disorder here. So let's, for the time being, just take this concept. Then we're going down the line. We have other types of schizophrenia and psychosis, which is good. We want those. And then we come across something we also want to exclude. This is drug-induced psychosis. As you may remember, we mentioned that we do not want to include those in our phenotype. So let's also choose them. And we have organic psychotic conditions, something that we also know we do not want to see. So let's choose that. And opioid-induced too, because it's technically drug-induced. So for the purpose of this tutorial, I'm going to stop here. But of course, when polishing the concept set, I will want to look through other codes as well. So what we want to do with those, we are going to go down and exclude them as well as their descendants. I'm going to click Add. And now when I go to concept set expression, I see our initial code, psychotic disorder, as well as those that we decided to exclude. What we're going to do now is we're going to go to the Recommend tab and look at what Atlas recommends to us. So basically, Atlas has some good machinery to recommend you concepts based on several types of relationships. Let's explore patient context first. So what does it mean? Patient context is a group of codes that are frequently co-occurrent to what you already have included. So what we have here, we have dementia, we have different disturbances of consciousness, altered mental status, dementia, neurosis, delirium, suicidal thoughts. All of those things are really co-occurring with psychosis frequently. We know that. However, we also know that we don't want them in our phenotype. And then going downwards, we see hallucinations. So hallucinations is definitely a symptom of psychosis. However, it is a very, very broad term. And for the purposes of our study, we do not want to include them because they would also mean lots of other diseases. They can occur in many other disorders. However, after them, we have delusional disorder. This is actually an umbrella term for a group of actual nosologies, disorders, basically, which we do want to include into our phenotype. And why do we know it? Because we did clinical description and literature search. So let's, for the time being, choose it, go downwards, click on descendants, and add them to our concept set. So what changed here? We have everything we had previously, as well as delusional disorders with descendants. Let's explore, for now, other types of relationships we have here. So there are different types of lexical matches via standard codes and source codes, which is what it says. It's lexical comparisons, as well as searches through ontology, basically the parents of the codes you have and the descendants of the codes you have. So once again, I'm going to stop my search through the recommend tab right here. But when creating and polishing the final concept set, of course, we would need to look into that in more detail. And so now what we could do is we could check the included source codes that we have in our set right now. So as you may remember, in the clinical description, we had some ICD-10 codes, and it is a terminology many of us are probably very familiar with. So let's limit our search right now to only them and look at them. So we would be rather happy here because we have what we really wanted to see. We see different types of schizophrenia, all those F2X codes right here up to F29. However, you may also remember that we wanted to include some other codes into our phenotype. Those were brief affective episodes, manic and depressive, with psychotic features. So how would we add them here? Let's go into the search tab. And one of the codes that was found in the literature is F30.2. So let's just type it in search. And we know it is an ICD-10 code, so only ICD-10. And here we have it. It's mania with psychotic symptoms, however, it is non-standard. And we are working with standard to facilitate network research. So let's go here. And let's go to its related concepts and choose a non-standard to standard relationship. So here we have our brand new standard mania with psychotic features concept. We can tick it and add it to our concept set with descendants. So let's do that. However, I want to stay on this page for a bit because actually I have a question. Why didn't we have it in our concept set to begin with? Well, the answer is that if we go into its hierarchy, we can see that when all other codes were in the psychotic disorders hierarchy, this one is actually in mania hierarchy. Its parent is called mania. So it is a totally different branch of hierarchy of psychiatric disorders, basically, in OMA vocabularies, and that is the reason why we didn't have it in the first place. So right now, our concept set looks like this. We have what we started with. We have some exclusions. We have other additions from recommend tab and from search. And this is where I'm going to stop this tutorial for now. However, as I said, you would want to look through other recommendations and possible exclusions too. And I'm going to pass microphone later. Yeah, thank you.
Thanks so much, Tanya. This is a wonderful demo on the concept set that ended up being quite complex, and it's very nice to see how your description translated into the thinking and decision making as you were going through the concepts to see if you want them in your concept set or not. And as we're moving from concepts, from building the building blocks concept sets to attaching the logic to these concept sets to create clinical definitions, I will share my screen back again, and I will pass the mic to Kevin, who will walk us.
I took the screen. It's fine.
Oh, you took the screen. Wonderful. Awesome.
So thanks, Anna. And building off of what you were talking about before with the clinical description of Crohn's disease, we'll expand this discussion a bit to the broader condition of inflammatory bowel disease, which takes on both flavors of Crohn's disease and ulcerative colitis. And as we know, as we just talked about, finding concept sets and finding the clinical definitions of things based on code lists is a key piece to this. And obviously, a lot of our definitions take one code or greater than one code or two codes as a base definition. However, a lot of these complex conditions, if you really think about it, some of these conditions can go on for many years. They can relapse and remit. And so different logic may need to be built in to have clinician specialty as part of a base definition, or different treatments and/or take into account other logic. And so I'll take a little bit of time going through some of the logic. So here's one definition of inflammatory bowel disease that just takes greater than one or more IBD diagnoses. We took a published, validated algorithm that really sought to get at a very specific and be used to define incident diagnosis. And we converted this clinical definition and phenotype that was done in claims-based environments into the Odyssey Atlas instance. And Jamie Weaver really helped us build this Atlas cohort. And you'll see right off the bat, 4 years of prior observation period of time to truly get at incidence. And many of our databases, then this would make it very, very specific. And a first diagnosis from a specialist with another diagnosis of a specialist within a year. And then a variety of no prior therapies based on, except if it was used to treat other conditions, to truly define an individual that had incident IBD. And I can switch to our, oh boy, this is where I fail. Okay, our cohort definition, which we were able to put out into the public Atlas system. And so here's a condition occurrence of inflammatory bowel disease for the first time in a patient's history. And then we have several of these inclusion criteria that are satisfied, or that need to be satisfied to get at the specific incident diagnosis of IBD. And so obviously, databases that don't have specialist information are not going to be able to comply with these types of definitions. So you still need to know your underlying data sources that are contributing to these. But you can see that throughout, you can build these complex logic-based systems to really get at a complex clinical definition. And I don't think I was going to go through all of these, but you can see how Atlas can be utilized to identify these. So, Anna, I was keeping it very brief because I wanted to leave some time for questions and discussions as well.
Sure, and we, in fact, do have more time.
There is a good question in the chat there about the extent to which specialty information is captured in a lot of the OMOP databases, because it would be very, very valuable as an asset. So just curious about your own empiric experiment or experience with the definition that you're proposing there, and how it's run in data sources that you guys have access to.
Yeah, so if you meet a gastroenterologist, they will tell you that no one has IBD until a gastroenterologist tells you that you have IBD. I think that may be true for many of our other fellow subspecialties on the line as well. And so, yes, if you run this in a database that does not have good capture of specialty, it will look like you have 0 people. Do you have 0 people? No, there are really people in there who have IBD, but because once you put in these specified logics, you will lose those people. But if you truly want to get IBD diagnosed by a GI physician, then we're going to need better data. But I think I've been screaming for better data for most of my career.
One other thought there, I couldn't remember if it was in your definition, but I think one of the reasons that might be the most trusted source is that they typically are the ones running the camera up. So if there's a procedure occurrence of colonoscopy, maybe that would be a good surrogate that might be better captured in our network of data sources.
Yeah, so absolutely. Refining logic based on available data is important. I would argue that as you're planning your clinical descriptions to stay agnostic to how the data is, right? You need to be focused on what the clinical concept is and the clinical idea first, not backing into it based on the data pieces. But then we do need to be very mindful of what data sources are contributing to various network studies and how these phenotypes would operate in these different situations.
Great, thanks.
Maybe as a general note to Evan's question, I think there's two things. One thing is that our tools allow us to model a logic based on specialty, and the ETL and the OMAP itself include that information in a very structured way, in a way that you can retrieve it in a tool like Atlas. We'll talk next week about evaluation of those design choices that you will make and how it would look at a particular data source, and that would be a great example where it might work in some data sources and might not work on others. And I think that's the experience that Kevin had when he actually ran this in internal data sources. You'll be able to understand that measure of loss in every database also compared to each other. And I think the other point is that it's not, many times it's not an ETL, because I think the question in the chat was like, do we have it? Do we have that information available in the OMAP instance? Again, that also depends on the institution ETL, but there is the ability to make it available. In our cases, we found that when it exists in the data source, and we're able to capture it, but it's something that you necessarily will need to evaluate.
And to add on to what Oz is talking about, it's not just the data, it's understanding the provenance of the data and why the data was collected, right? So in a UK-based, GP-based database, you could be diagnosed with IBD once, and you really do truly have IBD. Same with diabetes, because you're not then getting billed for that every single encounter. It may be an entirely different phenotype that operates well in that type of environment versus a United States system where you might get diagnosed with IBD just to go and get the prior auth approved to go and have the colonoscopy. Do you have IBD? No, you don't. You have one code for IBD to get yourself prior auth to be able to even have the colonoscopy, that then the GI doc would be able to make that diagnosis. And so these are some of the things where we need to understand how healthcare is provisioned, as well as how data is collected and how that data is provenanced into our various data sources.
And actually, to Az's point about the evaluation, I want to make sure that we also touch on the next steps for study leads and those who want to participate, and then we can talk more about what we were talking about, just to make sure that we cover this. For the next steps, for the study leads, we have a specific point in time this week as opposed to previous week. If you want us to run cohort diagnostics on your cohorts so that you can examine them and see what kind of patients you capture, we will need you to indicate in the spreadsheets which cohorts are ready by the end of the business day on Friday, so that we can run it over the weekend and discuss it next week. So for the study leads, please engage your the people who said they're interested in the channels to come together to build the cohorts together. We have 2 office hours, Wednesday 10 a.m., Friday 9 a.m. that you can come to if you have any questions, if you want coordination, if you want to pull in more people, anything else, come to the office hours or shoot us an email. And the expectation is that if you want us to run the cohort diagnostics to look at the patients this week, please have the cohorts or the subset of the cohorts ready by Friday. Those who want to participate, if you haven't already, please reach out to the study leads so they have you in the books. Patrick was very nice to tag people in the channels, but of course there may be more people who become interested in the studies. Please either reach out to the study leads or to me, Aza, or Gotham to participate in cohort building this week. And also come to the office hours on Wednesday, 10 a.m. and Friday, 9 a.m. Eastern Time. All of the meetings are happening in the work group, phenotype development and evaluation. If you don't have access to the work group, please let us know. We will add you. And now I'm back to your fun conversation, guys, about Crohn's disease, which I learned should not use apostrophe. That was a very useful call for me.
I know one more comment for next week, since you mentioned that we have about 60 definitions that were in the list that exist in our library. For study leads who are not aware and didn't see that, if you listed your definition in the tracker that Anna made, I went ahead and I gave the cohort ID for the existing similar phenotype in the library, and that would be your starting point if you don't want to start from scratch for both concept sets and a logic. But come to the office hours if you're not clear. But if you open that tracker and your phenotypes are there and the definition exists in the library, I already went ahead and put the ID for you.
Quick question. If the definition exists in the library, do you guys want a clinical description? And some in the library don't have a clinical description, and maybe it's a good way we can benefit the broader community by contributing one. And I just didn't know if we wanted to be updating existing phenotypes with clinical descriptions.
How would you know?
If we didn't develop them.
How would you know that something in the phenotype library fits your study if you don't have a clinical description? So yes, please do have one. And
all I'm saying is there's lots in there that don't have clinical descriptions, so we're happy to kind of configure ones that seems fit for the way the definition is configured.
You should have clinical description that fits your study specifically, not what's in the library, but what fits your study specifically.